Greetings. This is my project on biotic and abiotic factors. My name is Sabrina Garcia, and let's begin. Okay, so as you know, the learning objective of today is for the student to be able to refine scientific models and questions about the effect of complex symbiotic and abiotic interactions on all biological systems, from cells and organisms to populations, communities, and ecosystems. The student is able to also design a plan for collecting data to show all biological systems, which is me, obviously. And Okay, so what are biotic and abiotic factors? Well, let's begin. Biotic factors meaning related to life or living factors, of course, such as plants, animals, fungi, whatever, protists, and bacteria are all biotic or living factors. In fact, we as well are humans, and we are a biotic factor. Abiotic meaning not alive, are non-living factors that affect living organisms. Environmental factors such as habitat, pond, lake, ocean, deserts, mountains, or weather such as temperature, cloud cover, rain, snow, hurricanes, etc. are all biotic factors. Abiotic, sorry. So this is a great example of what I'm trying to show you. Biotic factors are also producers and consumers, dread-to-voids, decomposers. Okay, so for the beginning of this, I have to try to explain. I'm trying to explain to you cell activities are affected by interactions with biotic and abiotic by either cell density, and for that. I want to start off with density dependent, meaning that the population will grow very fast because of abiotic and abiotic factors. It will level up because of the density of things that we have logistic growth, and so the population growth begins slowing here. Okay. Okay, so temperature and stuff like that. So also, organisms or activities are affected by interactions with biotic and abiotic factors. So a good example of that would really be nationality, which are new individuals are formed, and biotic potential has the ability to achieve the maximum birth rate at ideal conditions. So with that being said, of course, the ability to achieve the maximum birth rate at ideal conditions. So it's basically like a birth rate. It's a lot of births and whatnot. Okay. So this is a good example. Take a look at it if you like. It's about really number during the year, the births, expenses, years, and it just starts from the bottom. It's 0 to just a lot of years. Okay, so nationality rate. With nationality rate, it's the number of births per 1,000 individuals per year. There are a lot of differences between the nationality rate and mortality rate, but it also it increases the population size and its density. It is the rate at which new people are added to the population. Mortality rate. The mortality rate is the number of deaths per 1,000 individuals per year. It decreases the population size and its density. It is the rate at which people die. Sorry. Okay. So, that being said, so with organisms being affected by interactions with biotic and abiotic, predator-prey relationships are also a big factor and to talk about and how they're related to this. So predation is a great example of biotic. As a prey population builds up, predators may feed preferentially on the species. So as you see, animals eating, consuming their beasts, and Okay, so for this graph here, in this graph we see that the number of organisms started to level off for bacteria because it's cell dispense. And eukaryotic or multicellular organisms blows up as well. So what are algae, right? So for C, the stability of population communities in ecosystems is affected by interactions with biotic and biotic factors. Algae blooms is a big concept. An illustrative example. Um, so, what are algae blooms? Algae blooms form in fresh water when cyanobacteria blue-green algae grow quickly and form scums or mats in the water. Some blooms can produce toxins harmful to people and animals. These are called harmful algae blooms. A good example of what that is also red tide. Red tide is it's a kind of like a seasonal thing that happens but it's a common name for a phenomenon known as also algae bloom, which as we just discussed. What it is caused by a few species of dinoflagellates. At the bottom takes on red or brown color as you see here. Okay, so we have a picture here of a mammoth being saved. As you can see in the background, I don't know if you could kind of see the red tide. So red tide has affected our living mammals under the sea. An algae bloom of southwest Florida called Florida red tide has killed 174 manatees since January, the highest number to die from red tide in the calendar year. Only 12 were saved, and red tide events have also caused fish killed in large numbers, by the way, and stranding of manatees and whales. For example, a red tide event in Georgia's Bank in the Gulf of Maine resulted in the death of 19 humpback whales. As you can see, red tide is not really that dangerous to us humans, but can cause certain respiratory irritation to people who constantly are surrounded by like surfers, biologists, anything that really humans are really interactive with the ocean with red tide. Eating the shellfish from harvested during a harmful algae bloom infection can also kill humans because it affects us, especially having it in our organisms. Well, that concludes. That really explains our whole project, and I hope you learned something off of this. And thank you for watching.